In Chapter 9, we are going to learn how to go from a logical design to a physical design. Chapter 9 is essentially phase 2 of your project. It'll probably take us a couple of class sections to get through Chapter 9. We're going to define the physical design. Some of this stuff is going to be a repeat, talking about foreign and primary keys. We'll talk about how to link tables properly. When there's a one-to-many relationship or a many-to-many relationship, how do you create those linkages? We'll talk about something called anomalies. Anomalies. Anormal. So problems that could happen in your database. Then we will learn how to normalize your database, a term we used before, but we're going to really get into it in this chapter, to the third normal form. Remember I told you there are actually 7 normal forms? No company cares about it beyond the third normal form, so that's all we're going to think about. Then we're going to look at it from a totally different perspective. How do you go about doing it if you just use your logical designs and nothing else? How do you go from a logical design to a physical design? And then finally, data validation, because a physical database includes that stuff we called metadata. Remember metadata? And so data validation will be part of the physical design of your database. Okay, so let's just go back through what a physical database is. And this is all about relational databases. We're not thinking about hierarchical or anything else except as it relates to relational databases. So the primary construct of a relational database is a table, just like an Excel spreadsheet. It has rows and columns. And just like an Excel spreadsheet, you might have multiple worksheets which would represent multiple tables. Each table either represents an entity or in some way represents a relationship between entities. And of course, for it to be a database, the tables have to be properly linked. As we know, the columns in your table are the various attributes that define that information. It could be the customer, and then it could be their name, address, etc. The rows are the various records or the various customers for a customer database. So each row is unique and it represents one instance of that table. The primary key, it uniquely identifies a specific row. It has to be unique. You cannot have 2 records on the same table with the same key. Each one must have a unique primary key. Now it might be a single attribute or it could be multiple attributes, 2 or more. If it's 2 or more, it's called a composite key, or the way I usually call it, a concatenated key. 2 or more fields together give you a unique key. As we said, there are 2 different nomenclatures in our 2 different books. So the primary key could be either a single underline or a double underline. If it's a single underline, then your foreign key is an asterisk. If it's a double underline, then your foreign keys are a single underline. That's the relationship. So for instance, the customer ID would be the primary key for a customer table. Why wouldn't you use customer name? It may not be unique. If you're a big company and you had somebody named John Smith, you'd probably have more than one. The foreign key appears in one table and it points to a primary key in another. You can have as many foreign keys in a table as you want. There's no limit. You could point to as many directions as is appropriate. And again, if you have a primary key that's a single underline, then your foreign key is an asterisk. If you have a primary key that's a double underline, then your foreign key is a single underline. An example, ignore this T right here. A customer ID would be a foreign key on a cash receipts table. So you got some money. You're only going to get money from a single customer. So you got a check. The check's not for 3 different customers. It's only for a single customer. So on the cash receipts table, it's going to point to the customer that cash receipt is for. What do you think might be a foreign key on a cash disbursement table? If cash receipts has a customer as a foreign key, what would be a foreign key on a cash disbursement table? Raise your hand. That might be the primary key, possibly. But it may probably not be a check number of some kind. Not a customer ID, no, this is cash disbursement. A vendor ID, you're going to be paying a vendor. So you'll be pointing to the vendor that you're paying. In the same way that on a receipt, you're pointing to the customer from whom you're getting the money. And just a little bit of ahead of ourselves. I want to see if anyone gets this. While you'd put the customer ID on the cash receipts table, you can't put the cash receipt on the customer table. Do you know why? Anybody want to take a guess at that?
They don't receive cash from you.
Well, they don't, but that's not the reason I was thinking of. If you have a good customer, you're going to get cash once. Yeah, you're going to get cash all the time from them, right? So you can't put it on the table. How do you put, that's a multiple repeating field that you can't put on the customer table. So the way you do that relationship is by putting the customer on the cash receipt table because it's just one customer. We'll come back to that. It's a very important concept. Okay, so let's go with converting an ER diagram to tables. Steps 8 and to some degree 9 in our event-oriented modeling approach from chapter 8. So when you convert a diagram to the table, let's say an ER diagram, you have to create your fields. So you've somehow defined your attributes. You have to create fields for those attributes. You need to designate primary keys, etc. Here's what you do. Let's say you have 2, and we're going to see this in action probably more times than you're going to want to. Let's say you have 2 tables, and they have a one-to-one relationship. A one-to-one relationship. It is okay, in fact, your textbook tells you to, I disagree a little bit, but it's okay to combine them into a single table. If it is truly a mandatory one-to-one, every time this happens, that happens. Every single time. And as you look into the future, every time this happens, that's going to happen, and they're 2 separate entities, then you can combine those into a single table. If, on the other hand, there's some optionality or some potential for optionality in the future, you should not combine them because then you just have to separate them in the future. So it's a mandatory one-to-one relationship between 2 tables. Then it's really one table. If you have either a one-to-many relationship or a many-to-many relationship, so either this or this, either of those scenarios, you then would create a separate table for each of this entity. So if this is entity 1 and this is entity 2, you'd have 2 tables. And if this was entity 3 and this were entity 4, you'd have 2 other tables. You'd have separate tables for each entity when they're not mandatory one-to-ones. If it's a one-to-many, customer and cash receipt, just like we were talking about, customer and cash receipt. A customer can have many cash receipts, but a cash receipt can only be for one customer. If it's a one-to-many relationship, you post the primary key from the one side to the many side as a foreign key. So the primary key of your customer table is customer number, right? That becomes a foreign key on your cash receipts table. That's kind of what we talked about 3 or 4 slides ago. With the idea being that if you want to learn about your customer, when you're looking at a cash receipt, you just go from this customer number right there, and it'll point you to the correct customer. So you take, the way this is described is you post the primary key from the one side onto the cash receipts, onto the many side. So let's just say you have 5 cash receipts for customer 1, 2, 3. Each one of those cash receipts is different. You have cash receipt 1, 2, 3, 4, 5, right? They're separate records, but each one of them will have the same customer number on them. All of them pointing to the same customer. Okay, so a vendor sells many products. A product would be an item number, a vendor would be a vendor number. Which one of those is posted on the other record? Is a vendor number posted on the product record, or is the item number posted on the vendor record to create a one-to-many relationship? Well, the correct answer is the product number would be posted on the vendor. No, the vendor number would be posted on the product table because there are many products for a given vendor. So the one-to-many, if a vendor sells many products, the one side is posted on the many. The one side is posted on the many. The many-to-many relationship. The many-to-many relationship. This is the thing that differentiates relational databases from all other database types. It permits the many-to-many relationship. You have a sale, and you have items. When you make that sale, it can be for one-to-many items, and an item can be sold in really 0-to-many sales. An item might not be sold at all, or it could be sold many different times to many different customers. This is a many-to-many relationship. The key to the sale, let's call it the invoice number. That's the primary key here. Let's call this the item number. That's the primary key there. Okay? Now you cannot place each of the primary keys on the other table because, again, you don't know how many you're going to have. It will just be a list of stuff. That'd get very messy. So what you do is you create a new table called the sale item table. And you get rid of this. Okay? And the sale item now has a concatenated key. Remember that term, concatenated key? It has the invoice number / item number as a 2-fielded primary key. And now, with that, what's the relationship between an invoice and a sales item? One-to-many. A sale could have many different sales items in it, but a sales item can only be for one sale. This invoice number will be the same as that invoice number. And you create a relationship here. So you now have items that you have a sales item relates to only one item, but it could be many there. So by creating this table right here, called a relationship table, with a concatenated key, you now have created the many-to-many relationship you need between cells and items. Okay? We'll talk more about this table. Now this table, I'm sorry, don't take a picture of me. This table might have no other information in it at all besides the key. It's possible that you might have other information in here. For instance, if it's a negotiated price, so for the price on this sale is different than any other price, you might have to have the price field on this sale for that item because you negotiated a specific price. If not, then it would just be on the item table. So this table could have just a key or other information that's unique to the relationship. Questions? You'll see it in action in a moment. It's important to note that you might have more than two tables in the relationship. Generally speaking, there are two, but it's not impossible to have multiple tables in a concatenation. And what this says is if there are any attributes that are unique to this table, you move them here. Otherwise, you leave them up here. Let's go through a kind of a little made-up example here. Salespeople and cell phones. You work for a sales organization. As soon as you join the firm, as soon as you join the company, they give you a cell phone. That's your cell phone. It's yours and only yours. You have it from the day you join until the day you leave. It's a truly mandatory relationship. You have to take that phone even if you don't want to. You can't have more than one phone. A truly mandatory relationship. You could create a single table out of these two entities. You have a salesperson entity, right? That's a thing. And a cell phone is another thing. They each have attributes associated with them. You can create a single table for them, called the salesperson phone table, if you wanted to, or the salesperson table. I don't care what you call it. And the key could be either really the salesperson number or the phone number. Doesn't matter, but salesperson number is probably more logical. You could do this. I would say this is, when we learn about table normalization, this is against the third normal form. This is only, in my view, the second normal form. So even though they say you could do it, I'm not a big proponent of doing this, but it is legal. If you know for sure, it'll always be the case. Create one table from two. Here's the one-to-many. You have a cell phone. Might have one-to-many salespeople associated with it, and a salesperson can only be associated with one cell phone. Okay, I'll paint the scenario. You're a sales organization selling to Walmart, and you just want to be there for Walmart when they call. So you have a team of 4 salespeople supporting Walmart around the clock, 24 hours a day. And what you do is you just hand off the phone to each other as the time goes on, so that somebody on that sales team will have that phone and be ready for a phone call at any time of the day or night, weekend, during the week. So you might have one cell phone and many salespeople. That's a one-to-many relationship. So what is the one side? What's the one side of this? You can see it from the picture. Cell phones. That's the one side. And the many side is the salesperson. So the primary key of the one side is posted as a foreign key on the many side. The primary key of the one side is a foreign key on the many side. So you've now created a one-to-many relationship in your table. phone number is the foreign key on the salesperson table. I don't know if you can see this thing right there, that little thing that looks like a bug, is an asterisk. Many-to-many relationship. In this scenario, it's really Walmart. You got a lot of phones for your Walmart team, and maybe you have one phone that for calls from one guy, another phone for calls from the VP, who's a woman, and all this together. And so you have a many-to-many relationship between cell phones and salespeople. Again, you want to really be supporting them well. You'd have your cell phone table, your salesperson table, and you would create this concatenated table or relationship table with a concatenated key called the salesperson cell phone table with a concatenated key on that. And none of this other information is unique to this relationship. So there's no other attributes on this table in this case. So that's a mandatory many-to-many relationship. You see, two entities become three tables in that case. I'm sorry? No foreign key. In fact, it's a good question. These concatenated keys right here almost serve as a foreign key, going in both directions. It's really what they're doing. They're a foreign key going in both directions. But there's no separate foreign key. You don't need it. And you'll see sometimes in the textbook, and you don't have to do it for me, that you'll see this will also have the asterisk up here, underlined and the asterisk, to show that it's kind of a foreign key as well. I don't care about the asterisks. Definitely underline it. It is a primary key. Optionality. Anybody remember what optionality is? Optionality? What does it sound like it is? The zero option. You may not have any. A customer may not have any sales, or a piece of inventory may not have been sold. So optionality allows for the zero option. When you have a relationship that includes an optionality, even if it's something that looks like this, zero to one and one to many, you would treat this, once you have an optionality in there, you treat that side as a many side. You treat it as a many side. So you would treat this relationship as a many to many. Once you have an optionality, it becomes a many. And the reason for that is if you didn't and you treated this just like a one side, if the situation were one of those situations where it was really a zero, you'd have a foreign key with nothing in it, pointing to air, and you'd never want to do that. You don't want to have foreign keys in your database pointing to air, because you don't know exactly what's going to happen. It's unpredictable. So you treat it as a many to many so that you don't have an important field, a foreign key, empty. You never want to have a primary key empty for sure, and you never want to have a foreign key empty either, because it's unpredictable. So here's an example. A cell phone is always given to a salesperson, but a salesperson may or may not be given a cell phone. Maybe they're new and they're not ready for them to answer phone calls from customers. They don't want to take that chance. So, we can, so this is like a one-to-many, right? So what do you do when you have a one-to-many? What do you do with a one-to-many relationship? It should be ingrained in your head. You put the key of the one side on the many side. So you put salesperson on cell phones. Put the key from the one side to the many side. Okay? Okay, here are really five critical requirements of any table you build. The first one is really two: entity integrity and referential integrity. Entity integrity means the primary key has to be unique and real. In order for any one of your entities to be valid, it needs to have a unique and real primary key. Referential integrity says you have to have a foreign key that points to a real primary key somewhere else. You're referring to a primary key, referential. Your foreign key is referring to a primary key that actually exists. Other requirements: every attribute has to be unique. We talked about this. So if you have two fields for address line 1 and address line 2, you have to call one address 1 and address 2. You just can't call them both address. This is very important when you do your implementations. It's just a limitation of the database management systems. If you have a field that's on multiple tables, and really the only time that should happen is when it's a primary key on one and a foreign key or a concatenated primary key on another. It's the only time you should have a field occur more than once. They have to be specified when you set up the metadata as text, numeric, currency, whatever it's going to be, the same exact way on every table. It can't be text on one and currency on another. It has to be identified exactly with the same metadata on all your tables. So it's very important when you set up your foreign keys that you do that. Each attribute of a record must be single valued. That just goes back to the reason why you put the one on the many in a foreign key, not the many on the one. Of course, otherwise you'd have a list of customer receipts or whatever you're going to call them. You can't have that on a single table. Everything occurs once. So you have to handle your cardinalities with new tables. Having fun? I'm hearing sighing. Wait till you get to do it. Then I'll hear moaning. Data normalization. So you have these tables that have been developed in some way, or you have data, and you want to take it from non-normalized data and turn it into fully third normal form proper data. You have to go through a process. And the good news is you're going to get to go through a process. Bad news is probably not today. If you don't have well-designed third normal form tables, you get something called an anomaly. And there could be three different kinds of anomalies. The first anomaly is an update anomaly. If you have a data item and it exists on multiple tables, then you have to change it on multiple tables when it changes. Let's say you had a customer address and you just didn't design your database right, so that address occurs in multiple different tables all over the place. When that customer changes their address, you've got to find it everywhere. If you designed your table right, you just have to change it once and everything's pointed to that customer table and the address will be there for whoever needs it. So an update anomaly occurs if you have multiple occurrences of data so that you have to do multiple updates when that data changes. An insert anomaly occurs if you cannot insert data without violating the basic integrity rule. So if you have new data you want to put in, let's say that, remember how we might combine the salesperson and the cell phone table into a single table? Let's say we did that and we were wrong. We actually have a new cell phone, but we don't have a salesperson to give it to. So we should not have combined them into one, but we did. Well, now you've got this problem. If you get a new cell phone, but you don't have a salesperson, which is the primary key of that combined table, you can't insert that cell phone. You can't put that cell phone into the system because you don't have a salesperson to associate it with. So an insert anomaly occurs when you have data you want to add to the system, but you can't because the primary keys don't exist the right way. A delete anomaly is kind of the opposite of an insert anomaly. You have that combined salesperson cell phone table, and you fired a salesperson, but you still want to have that, you don't want to lose that cell phone. So by deleting that salesperson, you're forcing yourself to delete the cell phone data, but you didn't really want to. So that's a delete anomaly. Okay, let's go through an example. So you have, this is like a flat file. This is not normalized data. And you have Ted Sanderson, 2 records for Ted Sanderson, customer ID number 10201. If you wanted to change Mr. Sanderson's phone number, you'd have to find both of his records and make sure to change it every time. Otherwise, you'd have inconsistencies between Ted Sanderson's data. So this is non-normalized data. This is first normal form data, not third. And you have an insert anomaly because to insert, an update anomaly because to update Ted Sanderson's data would require 2 updates, not 1. So that's an update anomaly. Okay. So how about an insert anomaly here? Same tables. In this flat file, you have a customer and the products that they bought and the selling price. Let's say you produced a new product, product P5555, but you've never sold it. You can't add it to the table because you can't add it without adding a customer, since most likely your primary key here is going to be customer ID, maybe concatenated with product ID. And so you can't add a new product without having it sold first. That's an insert anomaly. You cannot insert this data properly. This is my favorite. Okay. Bird Ryan. I just love her name. Bird. I assume it's her. Bird Ryan files for bankruptcy, and you want to delete her because you just can't think about it. What happens if you delete Bird? You delete the products and look at it. You're okay here because you've also sold that one to Diane Blair. This one, you're okay because you've also sold that one to Ted Sanderson at the same price too. This one, you haven't sold to anybody else. So if you deleted Bird, you would delete the products associated with Bird. In this case, you would lose all your information about product 7119. So this is a delete anomaly. You would not design a database to look like this, is the correct answer. We're showing you a bad database design that has problems. We need to get to a good database design. Okay? Okay, so let's go through the process of normalizing data. Okay, so let's normalize this to the third normal form. We're going to start off with totally unnormalized data, not even first normal form. And you know it's totally unnormalized when you have repeating fields. The idea that you can't, the first rule we had, you can't have repeating fields. You can't have the same information occur multiple times. So in this case, Dorothy Curry has 3 parking tickets. I assume they're parking tickets. Richard Macon has 2 parking tickets. This is totally not normalized. You can't even start to think about how to build a table like this. Right? Now you could take this, and when you start off building tables from non-normalized data, you walk it through from the 0 normal form to the first, to the second, to the third, etc. So this is the 0 normal form. You would take it to the first normal form by just taking this and kind of repeating this information for Dorothy and repeating this information for Richard. And so now here you've taken that data and you've put it in the first normal form. And you probably would have social security number and ticket number as your concatenated key, although I think here they used license plate number and ticket number as a concatenated key. It doesn't matter. Either one would work in the conversation. Well, what insert anomaly means something bad would happen if you tried to enter new data.
You can't add a ticket number unless somebody gets it.
Which probably makes sense, right? The ticket number itself, you're probably going to enter the ticket number when somebody gets it. Somebody got the ticket. But what else can't you change? What else can't you enter? A code. Yeah. What if there's a new code? This is an old example. They didn't have talking on your cell phone while driving. They want to add code D, $5,000. Talking on your cell phone while driving or texting. You cannot do an insert, when that law was created, because you don't have anybody who's created a ticket for a person yet. So the insert anomalies, you cannot insert a new code without having given a ticket. How about an update anomaly? Update. Phone number. If Dorothy Curry changes her phone number, you have to find all the records and change it multiple times. Okay, good. Delete.
If only one person got a certain code, you can't delete their thing.
Yeah, so what's an example of that? Good.
C1, Mason Richard.
Yeah. So Mason Richard goes in and he gets contested and he wins and they say, okay, let's delete that record. To delete that record, you'll lose the information about code and how much that code is worth, costs. So that's a delete problem. So all 3 of them, first normal form, doesn't work. So let's see what we can do. Let's create 2 tables. Let's create kind of the person table, the car registration table. See here it says that it's actually registered by its license plate number, not by Social Security. It doesn't change anything. And then you have a ticket. You have the ticket number. Then you add a foreign key on the ticket, because a ticket can be for only one person or one registration. But a car could have multiple tickets. So that's why you put the foreign key down here, the one-to-many thing, right? There's a one-to-many between tickets and people. Everybody get that? Kind of? You got rid of some of your problems, but not all of them. Can anybody see an update anomaly here? Well, I think that only occurs once. As a foreign key, that's not a problem. So be careful with that. Foreign keys need to be redundant because they need to point to a primary key. Same thing. Because it's a foreign key, you expect to see it on both tables. The only thing you expect to see on a second table will be a foreign key. Update.
Date.
What's that?
Date.
Not the date. What happens if you want to change the cost of code B fine to $50? You have to update it multiple times. So you have a problem there still. You're not fully normalized yet. Any of the codes. If you want to change a code, a fine amount, it might occur multiple times still. How about an insert anomaly? It's the same as the one we had before. If you wanted to insert a new code, you have to have a ticket first, since the primary key is the ticket number. How about a delete anomaly? Same thing. If you delete ticket 10231, you'll lose code C. So you haven't quite solved it here. You got better, though. You're not going to have multiple phone numbers. That was a problem the first time. So the second normal form, the first normal form is data is in the first normal form if you can successfully store it as a flat file. Data is in the second form if all data items can depend on the primary key. And you're pretty good there. But you need to take this to the third normal form. The third normal form is the second normal form, except it does not contain transitive dependencies. Anybody remember, I think it was algebra in high school, the transitive property in algebra? Transitive property, A there for B, B there for C. No, A there for B there for the C, A there for C. It's kind of transitive. Remember? So if you look at this information, you have a transitive situation. The fine relates to the ticket only through the code. So it should be A there for B, B there for C, A there for C. That's not right. You don't want this related to that. So the third normal form takes the second normal form and gets rid of transitive dependencies. The data in a table should relate only to its primary key. So here the fine amount relates to the code. And then the code is a foreign key on the ticket file, and all is good. So if you wanted to change the amount of code B to $50, you change it once, and then here they'll point to code B, and it'll change every time. So you've got it to the third normal form now by getting rid of the transitive dependencies, and the good thing about that is you're done. When you get rid of all your transitive dependencies and you're in your third normal form, your data is clean. So, in summary on that, don't worry, we're not done. First normal form removes repeating data. Second normal form removes partial dependencies. If you have a concatenated key and the data only relates to half of the concatenated key, then you have a problem. That's a partial dependency. The third normal form removes transitive dependencies. Okay. I'm going to give you guys a chance to do some thinking, so you don't have to hear my voice for a few minutes. Here's an example of professors and offices and phones and all that kind of good stuff. Here's non-normalized data. You have some professors that have some offices, and the offices have phones, and they're teaching some courses, and the courses have descriptions, And here, they've expressed, the professors have expressed when they want to teach their course. Monday and Wednesday at 8 a.m. Of course, they know nobody will show up. So, you now have, is this data good? What normal form is this? Nope. 0 has this repeating data thing happening. You can't do anything with that. You can't even build a flat file with that. Okay. This first normal form is easy. Just take this stuff right here, repeat it for both those lines. Make 3 lines of it. Take this, make 2 lines of it. Take this, take 2 lines of it, and you're done. Now can you do it? Okay. So you can get this from the 0 form to the first form. That's the easy part. So I don't even show that slide. It's so easy. So if this were the 1960s, you'd be done. But it's not. So then you would figure out what to do. Visualize this information. You kind of can feel that this should be separate from this. This should be separate from this, right? This professor kind of information and course kind of information. So let's say the first thing we do is we divide that. Certainly the repeating groups ought to be separate. That seems pretty clear. So you have a table which is a professor table with professor number as the primary key, and you have a professor course table with a concatenated primary key. Well, it's a concatenated primary key here, which acts as a foreign key. It will point you to the professor. That way you can have multiple lines for a professor with different information. But let's think about it. These descriptions here, do they relate to the professor in any way? No. These descriptions only relate to the course number. So this is the problem with not being in the second form. You have kind of the partial dependency. Description only relates to the course number, not to the entire primary key. That's a partial dependency. The credit hours also has nothing to do with the professor, it has something to do here. This stuff does relate to both the professor and the course. The professor has expressed their preference. So we have to do something to get rid of this problem. Notice the top table here is pretty good. It's in second normal form. You're good. The bottom table here is only in first normal form right now because it has these partial dependencies. So let's get rid of them. So now you kind of have, but now let's just say we split them. I think one of the tables said you split these. And you're going to have your vendor table with the vendor number. That's good. And then you have name. All good here. But what are we going to do here? Notice you have blenders. Vendor 2012 sells a blender, same item, to you for, I think that says $18. It's hard to read. And vendor 2010 sells the same blender for $15.99. What are we going to do? Well, I mean, you can't, this is a legal situation, right? This is a legal situation. A legal situation. You have two different vendors who are selling you the same product at different prices. Maybe it's hard to get it at the cheaper price from this vendor, so you sometimes have to buy it from here. Same thing with, guys remember what an iPod is? No, same thing with an iPod. Anybody have any ideas what we're going to do? I thought one of the tables, you talked about it. What would you do? You create a relationship table, vendor and item number. Now what are you going to do? What's going to be on that relationship table? You're going to add price as an attribute to that table. Price is not unique to an item. Price is unique to an item-vendor relationship. So the price would go into that relationship. Good. You were ahead of us. So you create this table, your item vendor table, and you would move price to that table because it's unique.